So today we are going to take notes on the pH scale. And in our first set of notes, we discussed a little bit about pH. And so hopefully you remember that the pH scale ranges from 0 to 14. And on the pH scale, an acid is going to be anything that has a pH of less than 7. Anything that has a pH of greater than 7 is a base. And if the pH equals exactly 7, then this would be neutral substance. Now, where pH comes from is a power of hydrogen. And so it represents the concentration of hydrogen ions in a solution. But concentration of hydrogen ions in a solution takes a long time to write. So instead, you can write it as hydrogen as an ion, so H plus, and then you can put that in brackets. And that whole thing right there means concentration of hydrogen ions. Much quicker to write. Now, if you remember, concentration is how we measure how much of something is in a solution. And the units were moles per liter, but we often abbreviate that with just a capital M. So that will be a lot faster for you to write than moles over liters. So our unit that we're going to use most often is this capital M. And there was an equation for calculating concentration, but in all of our pH, this is always just going to be given to you. The pH scale is based on a log scale 10, which means that every change in 1 of pH is a power of 10 change in concentration. Now, the nice thing is that you don't really have to understand logs in order to understand pH, because your calculator is going to do all of the work for you. So let's see what our equation is for calculating pH. So for pH, we're going to do the negative log of our hydrogen ion concentration. But remember, we can just write that as H plus in brackets. Now, on your calculator, you're going to have 3 simple steps. The first is going to be to press the negative key, not the subtraction key. Next, you're going to press the log key, and then you're going to enter the concentration of hydrogen. So if you're using a TI-84, for example, let me show you where these buttons are on your calculator. So here is the negative key. Here is the log. And then you're going to enter the concentration of hydrogen ion. So for example, if we look at number 1, it is H plus equals 1.0 times 10 to the negative 9. So in order to enter this into my calculator, I'm going to first hit the minus and then the log, and then I'm going to do 1.0 times 10. And I'm going to use the caret negative 9. So let me walk you through that again. You're going to do negative log 1.0 times 10 caret negative 9. And that here is our first example. So if you do that correctly, your calculator should tell you simply 9. So our pH of this solution is 9. Now, the next question is this an acid or a base? And because our pH is greater than 7, this solution would be a base. Okay, let's try example number 2. So let me just erase these marks so that you can better follow along. So for number 2, it says that the H plus concentration is 5.0 times 10 to the negative 3. Sorry, I wrote 13, 10 to the negative 3. So to put this in the calculator, I'm going to do negative log 5.0 times 10 caret negative 3. And if you do that correctly, you should get a pH of 2.3. And the question, is this an acid or a base? Because our pH is less than 7, this would be an acid. Almost exactly the opposite is the pOH scale. And just like the pH scale, the pOH scale ranges from 0 to 14. Why I say this is the opposite is because it's going to represent the concentration of hydroxide ions in a solution. So you can write this as brackets around hydroxide. Now, why I say it's the opposite is because on the pH scale, if we have an acid, it's when the pH is less than 7. But on the pOH, it's when we have a pOH of greater than 7 that it's an acid. So therefore, that means that if our pOH is less than 7, it's a base. And what's the same on both scales is that neutral is when it's exactly 7. It is very similar in the fact that the equation is pretty much exactly the same. In order to find the pOH, you're going to do the negative log, but this time, instead of the concentration of hydrogen ions, you're going to do the concentration of hydroxide. So you're going to plug those in the exact same. So we're not going to go through examples that are exactly like the 2 that we just did. But 2 more equations that can help you. Because 7 is neutral on both scales, what we know is that the pH plus the pOH can equal exactly 14. Some other thing that you can use is something called the ion constant of water, which is the Kw. And how we get this number is by multiplying our hydrogen ion concentration by our hydroxide ion concentration. And it's always going to equal this 1.0 times 10 to the negative 14. Now, why this number might sound familiar is because if you think that the pH and the pOH are 14, and then that is where this negative 14 comes from, because our negative log of Kw is going to equal 14. Now, out of these 2 numbers, I will do everything to avoid using the Kw. I almost always prefer using this equation right here, that pH plus pOH equals 14. And I'll show you how you can use that here. So for example, number 3, it says, calculate the pH value for a solution in which the hydroxide concentration is 1.0 times 10 to the negative 6th. So here I have the hydroxide ion concentration, and I can plug that into the most recent equation we talked about, pOH equals the negative log of hydroxide. So I can find that the pOH is the negative log of 1.0 times 10 to the negative 6. So let's practice plugging that into the calculator again. So in our calculator, we would do negative log 1.0 times 10 caret negative 6. And when I do that, I'm going to get that my scroll back up, that my POH equals 6. But if you look, trick question, it's asking for pH. And what I know is that my pH plus my POH equals 14. So if I just take 14 minus 6, I will get 8, which is going to be my pH. And then last part of this question, is this an acid or a base? Because my pH is greater than 7, this would be a base. Also, look, I could answer that same question with my POH. Because my POH is less than 7, that makes this a base as well. So it doesn't matter which number you look at. You should get the same answer. Okay, let's try another one. The pH of blood is 7.4. What is the POH of blood? So I know my pH is 7.4, and I'm looking for POH. And what I know from my equation above is that pH plus POH equals 14. So I can simply do 14 minus 7.4 and get my POH, which is 6.6. And it asks, is blood an acid or a base? Once again, I could either look at my pH or my POH. This time, because it was asking for POH, let's look at it. So my POH is less than 7, which makes blood slightly a base. So why would I ever use something like this KW number? Well, sometimes it's easier if you get the concentration instead of one of these numbers. But there's a way around that by simply using H plus concentration and your calculator. So step 1 for calculating pH from the concentration of hydrogen is to take the inverse log, and then you have to press the negative key again, and that should give you your pH. So let me show you where those things are on the calculator. So let me just erase. So on your calculator, you're going to hit first the second, and then you're going to hit the log, because if you notice above the log, it says in blue there, which is why we hit the second button, 10 to the x. So that's what we want to do. But then that's going to give you a negative number, and pH goes from 0 to negative 14. So then you really just have to make that number positive by hitting the minus key, which is what the second step says to do. And why this works is because our equation for calculating our hydrogen ion concentration from pH is 10 to the negative pH. So if you want to find the concentration of hydrogen, just do 10 to the negative pH. Similarly, if we have our POH and we want to find our hydroxide ion concentration, we can simply do 10 to the negative POH. So, question might be, if the pH of water in a fish tank is found to be 7.41, what's the concentration of hydrogen ions in the water? So how we would plug this into our calculator is by simply I erase these things, simply saying, since our pH is 7.41, I just went to hit in my calculator 10 to the negative 7.41. So in order to plug 10 to the negative 7.41 in my calculator, I'm going to just hit second log and then negative 7.41. And if you do that correctly, your calculator should tell you that the concentration of hydrogen is 3.89 times 10 to the negative 8. Now here I actually need a unit for the first time because it's asking for the concentration. And remember, the unit for concentration is just simply M. So it might seem like we've learned a lot of equations today, and the easiest way is to organize it into this little diagram that I'm going to draw for you. So the four things that we've learned how to calculate between are the concentration of hydrogen, the concentration of hydroxide, pH, and pOH. So the equation that can help you, and this is the one that I use the most, convert between pH and pOH, is that the pH plus the pOH equals 14. One I try not to use, but that is helpful sometimes, is that the hydrogen ion concentration times the hydroxide ion concentration equals 1.0 times 10 to the negative 14th. One that you will use quite a bit is to help you convert between hydrogen ion concentration and pH. And our pH equals the negative log of our hydrogen ion concentration. And similarly, we can use the same thing to find pOH as the negative log of hydroxide concentration. And then last but not least, in order to go from pH to the hydrogen ion concentration equals 10 to the negative pH. And if we want to go from pOH to the hydroxide ion concentration, it is going to be 10 to the negative pOH. So this little diagram can help you. For example, on our table here, if I want to find out the pH, if I'm given the pH is 1.60, to find the pOH, I'm going to use my favorite number first. So I'm going to do 14 minus 1.6, and I get 12.4. Then it's very easy to find our ion concentrations because for each of these, we're just going to do 10 to the negative. So for example, I'm going to do 10 to the negative 1.6 in order to find my hydrogen ion concentration. So I'm going to do 10 to the negative 1.6, and I get 0.025. For my hydroxide ion concentration, I can do 10 to the negative 12.4. So 12.4 to the negative, and I get something in scientific notation, which is just fine. I'm going to get 3.98 times 10 to the negative 13. And last but not least, I want to know, is this an acid or a base or neutral? And to me, the easiest thing to do is look at pH because that's the scale I learned first. So my pH is less than 7, therefore this is an acid. Okay, this next one, I'm starting with my hydrogen ion concentration. So I'm starting here. So to me, the easiest thing to do is to find the pH first. So to find the pH, I'm going to do the negative log of 2.56 times 10 to the negative fifth. And I get 4.59. Now, from there, to me, the easiest thing to do, since I have pH now, is go and find my pOH. So I'm going to do 14 minus 4.59, and I get 9.41. And then to go from pH to my only missing blank, the hydrogen ion concentration, I'm just going to do 10 to the negative 9.41. And again, I get scientific notation, which is just fine. I get 3.89 times 10 to the negative 10. Once again, is this an acid, base, or neutral? To me, the easiest thing to do is to look at the pH, which is less than 7. So here again, I have an acid. All right, our last one. So we've got a pOH. So to me, the easiest thing to do first is to go to the pH. And I'm going to do that by doing 14 minus 6.5. And I get 7.5. And then to find my hydrogen ion concentration, I'm going to do 10 to the negative pH. And I get something in scientific notation. Actually, no, I don't. I need to convert it to scientific notation. I get 0.0000000316. So I just need to convert that. So let me count my zeros. 1, 2, 3, 4, 5, 6, 7, 8. So I get 3.16 times 10 to the negative 8. Now I could use this KW number here, but to me, the easiest thing is to go back to my pOH and do 10 to the negative 6.5, in which case I get 3.16 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. Great. And this time, because my pH is greater than 7, this is going to be a base. Thanks for watching.